All right, finishing off 8-6, part 2 here. They ask us how many cubic yards of concrete are needed to pour 8 cylindrical columns that are 12 feet tall and 2 feet in diameter. Well, let's think about our shape here. Is definitely a cylinder, but we have 8 of them, right? So we'll have to realize, do we want the volume, lateral area, surface area? Since we're doing concrete, we want the volume. So we can do the volume of the cylinder, and then we'll take that times 8 to answer our question. Of course, since they want it in cubic yards, our best move is to change our dimensions in the yards first. So since there's 3 yards in a foot, we'll divide this guy by 3, and the height of this will be 4 yards. And then remember, we just need the radius of this, which is 1 foot, because the diameter is 2. But to change that into yards, the radius is really 1/3 of a yard in that case. So we'll start with our formula for volume of a cylinder, which is base area times height. I'm kind of in the mood to change that capital B to pi r squared because he's a circle. And then we'll deal with the height. So we'll sub all this stuff in. Pi times our radius. Remember, we want the 1 in yards. That's going to get squared times our height right there. And then we'll go punch this bad boy in. So I'll take pi times, putting that 1/3 in parentheses. It's got to get squared, then times 4. The volume of this one cylinder is about this. I'll write it down by rounding it, but I got to take this times the 8. So the volume is about, was it 1.4? Yes, sir, about 1.4 cubic yards. But not rounding that guy off, because there is 8 cylinders that we're going to pour the concrete on. I need to take him times 8. So times 8, and this is the number that we can round, about 11.2 cubic yards. Since we have to order to the nearest half a cubic yard, we will order 11.5 cubic yards. I should have said half a cubic yard. I may have said cubic yard there, and I'll put a cubed on it instead. So just volume of that cylinder times 8 in that case, but we had to change our dimensions into yards. Then it says calculate the weight of this piece of steel. So the weight means we want the volume of this bad boy. So we got 2 shapes that we got here. We've got ourselves a cylinder, and we've got ourselves a cone on top. They tell us how much the steel weighs per cubic inch. And the cool thing is all of these dimensions are in inches, so I don't have to do any converting. So let's do the volume of each one. Doesn't matter which one we do first. So how about the volume of the cylinder? That's going to be the base area times height, which we might as well change to pi r squared times the height. And I need the radius again. So here is the radius of this guy. He's that 2.25 divided by 2. So the radius is 1.125 inches. We will sub that guy in. So 1.125 goes in for the radius. The height of the cylinder is just the 4.5 inches. So pretty cut and dry on this one right here. Just got to punch him in. So that is not what I wanted to show. We will punch him in as this guy right here, pi times 1.125 to the second, and then that's going to be times 4.5, and this will be the volume of the cylinder is about 17.9, so about 17.9 cubic inches. Remember, this is like a solid piece of steel. That's why we found the volume. We'll do the same thing for the volume of the cone. So 1/3 base area. I'm going to just go ahead and go straight to pi r squared times the height would be the volume of the cone. The radius of the cone is the same as the radius of the cylinder, so that's pretty sweet right there. So 1/3 times pi times 1.125 squared, and then the height of that cone is 1.5, right? So we'll just punch all that in. 1/3, putting him in parentheses, pi times 1.125 squared times 1.5, and I got back about 1.99, so we can really call that about 2.0, about 2.0 inches cubed. And then we just add these together, so we can use the rounded numbers. We'll be okay on that. So 2.0, which I'll just do as 2, plus 17.9 for a grand total of 19.9. So the volume of the total is about 19.9 inches cubed. But they didn't ask that. They asked how much does it weigh. Well, this steel barely weighs anything per cubic inch right here. So we just take that times the 0.283. So I'll do 19.9 times the 0.283. Yep. And he weighs about 5.6 pounds roughly. So they don't tell us how to round, so I'll just write that all down. About we'll round to the nearest tenth, about 5.6 pounds. And pounds can be abbreviated as LBS. So it was just the volume of that. And then the last one of the day, man, is called the angle of repose, right? So I got a little video here. It's very short of what the angle of repose is. If we had some sort of like granule substance, be it like dirt or rocks or sand or anything like that, and there's no sound in this video, so I'm just going to talk while it plays right here, if I could get play to play, is you see how when they're pouring sand straight down onto this pile, the angle basically stays the same, and this is the angle that I'm talking about. I kind of snipped this out of the video real quick, but according to the description on this video, it's roughly like 35 degrees on here. As they keep pouring the sand, as I go back to the video, notice that 35 degrees like never really changes much, right? And when it does start to change, like there's going to be this avalanche. Sorry that the internet's lagging so much. So that angle stays the same. And there it got too big, and then all that sand just fell on an avalanche. This is called the angle of repose. It's just like what this particular granular substance, in this case it's sand. We might deal with rocks. We might deal with dirt. You know, in the medical field they deal with all kinds of different like powders to make these pills and stuff. But it's just called the angle of repose. It's just like kind of the max angle this thing can hold before it has an avalanche due to gravity right here. So what we got basically, it's always going to form a cone shape when they do it, and they give us like how tall this puppy is. So I'll go put that this dirt pile, so this is dirt, not sand, is 16 feet tall. It's kind of hard to write on y'all's worksheet because this picture is in black and white in that scenario. But it's 16 feet tall with a diameter of 40 feet. So don't really care about that diameter, care more about the radius being 20. So what you can draw, since it's so hard to see on your black and white copy, is we're going to get this little right triangle formed right here, that if I was to bring that out like this, the height of that cone is 16 and the radius is 20, and there's a right angle here since he's a right cone. They are looking for this angle of repose right here, which we will call theta. And we're taking ourselves way back to SOHCAHTOA on this guy. Because we have ourselves a right triangle, we can use SOHCAHTOA, and we're looking for an angle measure. So focus my attention on who this guy is in relation to theta, if he's opposite, adjacent, or hypotenuse. And he is opposite because he's right across the way. And then this 20, he is totally touching that guy. He is adjacent. He is definitely not the hypotenuse in this case, because hypotenuse is across from the 90. So we're dealing with opposite and adjacent. So that means we will use the tangent. So the tangent of the angle measure, remember we don't know him, so we'll call him theta, is going to equal opposite over adjacent. I could care less about reducing that fraction of 16 over 20 because we're just going to punch this in and get a wild little decimal anyway. So it's been a long, long time since we used SOHCAHTOA, but when we're missing the angle measure, that's when we do the inverse. And that's where the 16 over 20 and the theta switch places in this case. So we can go to our calculator, making sure he's in degree mode. If he's not in degree mode, ask a math teacher to change this guy. So I'll hit second tangent, so I get that little -1 on there. And then 16 divided by 20 And then the tangent inverse is about 38.7, so theta is about 38.7, but they ask us to go to the nearest degree, so we'll say about 39 degrees. We'll round that guy up. So not 38 degrees, but 39. So that's the angle of repose. For this particular dirt, it would like only have this angle right here of 39 degrees before, if you kept piling more on, it would start to avalanche down thanks to the gravity factor. Then part B asks how many cubic yards, how many cubic yards of dirt are in the pile. That's where we want to find the volume, but we got to change our dimensions into yards. So the height of this bad boy will be 16/3 yards because we need to divide by 3, and the radius is 20/3 yards in that situation. So volume of a cone, 1/3 base area, which is pi r squared, times the height. And we will sub our stuff in, 1/3 times pi times this nasty little boy of 20/3. It's got to get squared times the height of 16/3. And then we'll just punch all that stuff in and see how many cubic yards of dirt are in this pile. So clearing all this out to get out of the way, 1/3 times pi times 20/3 in parentheses, that's got to get squared, times 16/3. And I got about 248.2. They say round to the nearest cubic yard, so we'll do about 248. So about 248 cubic yards. 248 cubic yards. So the angle of repose. Just be careful on part B, because they'll probably give us the dimensions in feet, and we got to change them into yards first. Let us know if you have any questions, baby, and have a good one.